All right, so welcome to problem 4. This problem is going to be about limiting and excess reactants. We covered a little bit of this in the previous problem, which was about theoretical and percentage yields. However, this problem is going to be a little bit different, as there will be less information given to us about the reactants, and the process of determining which reactant is limiting and which reactant is in excess will be hence a little bit longer and a little bit different. So let's just jump into the problem. The problem has 3 parts. Part A asks us to write an equation for the formation of zinc iodide from zinc and iodine. Part B asks us to calculate the amount in moles of each of the reactants given the data, and hence determining which reactant is in excess. And part C asks us to calculate the mass of zinc iodide that will be produced once the reaction is finished. So part A asks to write an equation for the formation of zinc iodide from zinc and iodine. Now, I want to emphasize how important this is. It is vital and crucial to write a proper equation that is balanced in order to be successful in the rest of the exercise, because molar ratios play an important part. So this equation specifically is fairly simple. You'll just add zinc and iodine expressed as I2 because it's a diatomic molecule, and you'll just get zinc iodide. The 3 of them are solids, both of the reactants and the product, so it's fairly simple. But in the case that it were a little bit more complicated, it would still be crucial to have a proper, well-balanced equation of the reaction in order to be successful in the calculations. So yeah, part A is, as I explained, fairly simple. You just add zinc and iodine, expressing iodine as it is a diatomic molecule, and just obtaining zinc iodide. So let's just then go to part B. Part B asks us to calculate the amount in moles of zinc and iodine, and then, based on the data, determining which reactant is in excess. Now, this slide will be covering the first part of the exercise, which is underlined, calculating the amount in moles of zinc and iodine. So I just copy-pasted the equation here because, again, it's important. So first part is fairly simple. In order to calculate moles, again, you divide mass by molecular mass. Why? Because you're dividing, if you look at it from the unit side, you're dividing grams by grams per mole. So the grams are canceling each other and you're just getting moles, which is what you want. So for zinc, in the case of zinc, you basically divide the mass that is used, which is in this case 100 grams, by its molecular mass, which from the periodic table we know it is 65.39. If we do that, we get that the amount in moles of zinc is 1.53 moles. We do the same process for iodine. We divide the mass, which is 100, the same as in zinc, by its molecular mass. Now, it is important to note that as it is here, and as iodine is a halogen, it is a diatomic molecule, and you need to account for that when calculating its molecular mass. You must multiply its molecular mass from the periodic table times 2, as there are 2 molecules of iodine that are reacting. So you multiply 126.9 times 2, and that quantity, you divide 100 by that quantity to get the moles, and you finally get that the moles of iodine in the reaction is 0.39. So we now have accomplished the first part of that problem, which is calculating the amount in moles of zinc and the amount in moles of iodine. So let's jump to part 2 of section B, which is determining which reactant is in excess. Now, we know this equation, and we know that the amount of in moles of zinc is 1.53, and the amount in moles of iodine is 0.39. Now, to find the limiting and excess reactants, we need to divide the amount in moles by its coefficient in the balanced equation. Again, the equation is extremely important here, because yes, in this case, the coefficient is 1 for both of the reactants, but in the case that it weren't, it is vital for us to divide by that coefficient in order to get the correct limiting and excess reactant. So in this case, it's simple. You just need to divide the moles of zinc by its coefficient, which is 1, right? So 1.53 divided by 1, which is 1.53, and the same for moles of iodine. You divide the amount that was found, which is 0.39, by its coefficient in the equation, which is again 1, and you get 0.39. So once this is done, in order to check for the excess reactant, because they're asking for the reactant that is in excess, we would need to identify which of the reactants has a greater amount, no? Is present, has a greater amount in the reaction. So we have 1.53 moles of zinc and 0.39 moles of iodine. So the reactant in excess would be zinc, as it is the one that has the greatest amount reacting. So as zinc has a greater number, zinc is the excess reactant, and we would have we already have solved the second part of section B of the exercise. Now, part C asks us to calculate the mass of zinc iodide that will be produced. Again, the text box here, the little square, is the important data that we must use. So we know that the amount of zinc iodide produced will be the amount of iodine reacted. So why? Because iodine is the limiting reactant. As seen here, iodine is the limiting reactant. As iodine is the limiting reactant, it is the responsible it's responsible for how much of the products are produced. So we need to figure out the molar ratio between the limiting reactant and the desired product. Here the limiting reactant is iodine and the desired product is zinc iodide. So it is a 1-to-1 molar ratio, as seen. 1 mole of iodine is producing 1 mole of zinc iodide. So since there's a 1-to-1 molar ratio, the amount of zinc iodide produced is equal to the amount of iodine reacted. So we'll just take that 0.39 moles of iodine and get that the amount of zinc iodide produced is 0.39 moles. Now that we have the amount in moles, we want it in grams. So to calculate that, we multiply the amount in moles times its molecular mass. Why? Because we're multiplying moles times grams per mole, and we're canceling the mole unit and getting grams, which is what we want. So the amount in moles, we already know it's 0.39 due to the 1-to-1 molar ratio between the limiting reactant and the desired product. So we know it's 0.39, and we're going to multiply that by the total molecular mass of the desired product. The total molecular mass of the desired product would be the molecular mass of zinc, which is 65.37, plus 2 times the molecular mass of iodine, as it is a diatomic molecule. So it'd be 65.37 plus 126.9, which is the molecular mass of iodine, times 2. If you do that, you get that the mass of zinc iodide is 124.5 grams, and that would be finishing this exercise. I hope you learn a little bit more about excess, limiting reactants, and the role they play in determining how much of a product is produced, and how to calculate it. Again, the presentation is linked in the description if you find that useful, and thank you.